All right, today we are going to get into equations and we are starting with solving literal equations for a variable. So a literal equation contains more than one variable. They can be solved for a specific variable using inverse operations. Most real-world problems require the use of formulas, which are a specific type of literal equation. So if it has more than one variable, it's definitely a literal equation, and formulas fall in that category. So if you need to pause this to write down your definitions, please do. You want to be writing these down in your class notebook. So once you've got literal equation down as a definition, we said we are going to solve for a specific variable using inverse operations. So just a reminder of which operations are inverses. Addition and subtraction are inverses of one another. Multiplication and division are inverses of each other. What it means is that inverse operations are going to undo each other. So if I have subtraction, I can undo that subtraction with addition. If I have multiplication, I can undo that with division, so on and so forth. Okay, so in example one, we have the literal equations or formulas, and it tells us to solve for the specified variable. So in A, we are going to be solving for x. So my suggestion is that you somehow make a note of what you're trying to get by itself. And then once you've identified that, you're going to move everything else away from it, everything else to the other side of the equal sign. And generally when you do that, we start with the things that are furthest away. So the 4 is closest to the x because it's right attached. So the b is further away. We're going to start with that first. Because the operation there is addition, the inverse of addition is subtraction. So we are going to subtract b. Whatever we do to one side, we always have to also do to the other side of the equation because equations are like a scale that has to stay balanced. So if I take b away on one side of the scale, it's going to tip unless I also take b away on the other side. So when I take b away over here, these are going to cancel each other out. That's what inverse operations do. Now 12 minus b, there's nothing I can do with that. Those are not like terms, so I'm just going to leave it 12 minus b. And then I have 4x over here on the left. So my x is still not alone. I still need to get rid of this 4. The 4 right now is attached to the x directly, which means that's multiplication. So the inverse of multiplication is division. So that means I'm going to divide by 4. Whatever I do on one side, I have to do to the other side to keep it balanced. So these are going to cancel out, the inverse operations, and x is going to be alone. I am totally okay with you guys leaving the answer like this, 12 minus b divided by 4, because if you were going to divide that out, you would have to divide both terms. So you can do that if you wrote this 3 minus b over 4 or 3 minus 1/4 b, that would also be okay. It's just not necessary. Okay, so let's look at b. We have 5a plus 7 divided by x equals c. That's our literal equation. We want to solve for the a. So indicate what I want to solve for. The thing that is furthest away on the same side as the a is this x underneath. And fraction bars mean division. So I need to undo that division. Remember that division goes with multiplication. So the first thing I'm going to do is multiply both sides by x. That will undo this. So I have 5a plus 7 on the left side. C times x is just cx. Now I still need to get this a alone. Much like what I had over here, I'm going to undo the addition by subtracting. So 5a equals, the cx and the 7 are not like terms, so just cx minus 7. And then still need to get this a alone. This is multiplication, so I'm going to divide everything by 5. So a equals cx minus 7 divided by 5. And again, perfectly fine to leave it this way. You do not need to separate out the pieces of the division. All right, last one in this category, C. We're going to solve 3x minus 4y equals 7 for y. So that's this guy right here. So I've got this negative 4 and I've got this 3x. 3x is further away, and the symbol in front of the 3x is positive because nothing's written. Don't take the sign behind it. That goes with the 4. So to undo addition or positive 3x, I need to subtract because it's the whole thing. I'm not just dividing away the 3. I'm taking away the entire term. So these are going to cancel. Make sure you bring down that negative sign. It's still there. And then 7 and negative 3x are not like terms. So 7 minus 3x is how we'll leave that. Then still need to get y alone. I've got a negative 4. Now be careful. I chose this one on purpose because most people look at this minus and they think, oh, I'm going to add. No, the operation between the y and this number is not subtraction. It's multiplication. This is negative 4 times y. So that means if I want to undo it, I need to divide, not add. So I have y equals 7 minus 3x over negative 4. Okay, D, we have a word problem. I wanted to illustrate that. The equation T equals 3p plus 108 can be used to estimate the cooking time T in minutes for a stuffed turkey that weighs p pounds. Solve the equation for p. So I've got T equals 13p plus 108. I'm trying to solve for p, so that means I want to get rid of this added 108 first by subtracting. Again, over here, these are not like terms, so I'm going to leave it. T minus 108 equals 13p. And then the 13 and the p are multiplied, so I'm going to divide to undo it. And I have p equals T minus 108 divided by 13. That's the first thing it asked me to do. I solved the equation for p. Next thing it asked me to do is to find the weight of a turkey that requires 285 minutes to cook. So T is the time in minutes. So that means I'm plugging in 285 for T. So I'm going to do P equals 285 minus 108 divided by 13. It's taking a minute to think. Sorry about that. Okay, so 285 minus 108, enter, and then I was dividing by 13, so divide that answer by 13. So I've got about 13.62, and it doesn't say what to round to, it just says find the weight. So it said P was in pounds, so 13.62 pounds approximately. All right, last one. These are all specifically named formulas that we use either in math or in science. So we're going to solve for the variable that's over here. And it tells you what the formula is and what each piece stands for, because this is good to become familiar with these formulas you're going to see in other classes. So distance equals rate times time. We're solving for r. So d equals rt. If I want r to be alone, that means I need to get rid of t. Since they're right next to each other, that means multiplication. And I undo multiplication with division. So r equals d over t would be my answer there. Nothing I can do to simplify that. I'm going to solve this next one. Pressure equals force divided by area of the surface. And it says I'm solving for F. So it's F divided by A. We undo division with multiplication. So these will cancel. That will get F alone, and F equals A times P. Kinetic energy, we're solving for M, which stands for the mass. So I have K, kinetic energy, equals 1/2 mass times velocity squared. So if I'm solving for M, that means I need to get rid of two things. I need to get rid of a 1/2. Now, fractions are a little bit different. You've learned throughout junior high and middle school math that we get rid of fractions by multiplying by the reciprocal. So the reciprocal of 1/2 is 2 over 1, or just 2. So multiplying by 2 will cancel that. So that gives me 2k equals mv squared. I'm still trying to get m alone. It's multiplied times v squared, so I undo multiplication with division. So divide that away. M equals 2k divided by v squared. Next one is for gravitational energy. We are solving for h, which stands for the object's height. U is the gravitational energy, m is the mass, g is the acceleration due to gravity. So if we're starting with u equals mgh, and we're solving for h, that means I need to get rid of a multiplied m and g. Unlike in this one above, really, because these are the same operation, I can get rid of them at the same time. So I can simply divide by both simultaneously. That'll get my h alone, so h equals u divided by mg. All right, last one. This is Boyle's law. P1 and V1 are the initial pressure and the initial volume of a gas. P2, V2 are the final pressure and final volume of the gas when the temperature is kept constant. So we are going to solve this for V sub 2. So V sub 2 is what I want to get alone. That means I need to get rid of P sub 2, which is multiplied. We undo multiplication with division. So we divide that away, and then I have V sub 2 equals P sub 1 V sub 1 divided by P sub 2. And now I've done every single thing that they asked of me. Hopefully that makes sense how we use the inverse operations. And I've given you a ton of examples that you can use to help you with your practice.